Hello viewers, in this video I am going to provide the solution to this interesting exponential equation. We are asked to solve 2 raised to the power 3 plus 3 over x minus 4 raised to the power 3 over x equals 12. My first step here will be to split this part following this rule of indices, where a raised to the power m plus n would become a raised to the power m times a raised to the power n. So splitting this would give 2 raised to the power 3 multiplied by 2 raised to the power 3 over x. I bring down this other side. In bringing that down, I am going to reduce that index of 4 to a lower base. The 4 becomes 2 raised to the power 2, and this multiplies the 3 over x you have there, equals 12. The 2 raised to the power 3 from here is 2 times 2 times 2, which is equal to what? 8. Now the power you see here, I want to separate that power as 2 raised to the power 1 over x, all cubed. The 1 over x times the 3 there will go back to the 3 over x. Similarly, I am going to separate these powers. The 2 times the 3 there is 6. The 6 should be outside the bracket here. This 1 over 6, this 1 over x times 6 will go back to this and will remain the same. So this equals 12. Now we are seeing a common term here of 2 raised to the power 1 over x. So firstly, I'm going to say let 2 raised to the power 1 over x equals what? Equals y. So I'm going to substitute in y for 2 raised to the power 1 over x. So bringing down this whole expression, I'm going to have 8 times what? Y raised to the power 3 minus y raised to the power 6 equals 12. So how then do we solve this equation I have just obtained? I want to reduce this to a lower expression. Again, I am going to say let y raised to the power 3 equals p. Let y raised to the power 3 equals p. So 8y raised to the power 3 becomes what? 8p minus, now breaking this down, the y raised to the power 6 is y raised to the power 3 times y raised to the power 3, following the same rule of indices. So y raised to the power 3 times y raised to the power 3 will give y raised to the power 6. And my y raised to the power 3 is what? P. So that means here I am multiplying p by p, which is p squared, and this equals the 12. So I have just obtained another equation. It's going to be a quadratic equation. Let me arrange this well. Crossing the minus p squared to the other side will give p squared. Crossing the hp will give minus hp. And then I bring down the plus 12 equals 0. Factorizing this equation, our factors are minus 2 and minus 6. Factorizing the first part, that is going to be p into p minus 2 minus, our HCF here is 6, also into p minus 2 equals 0. So from here, p minus 2, p minus 6 will be equal to 0. If we solve for p, for each of those sides there, p will be equal to 2, or p will be equal to 6. But then, remember that we asked to solve for what? For x. And at this point, we said let y raised to the power 3 equals p. So if y raised to the power 3 is p, we can therefore say that y raised to the power 3 is equal to 2 by this side, and y raised to the power 3 will be equal to p, that's equal to the 6. How do we solve for y in each of this side? I'm going to find the cube root of each side. I'm going to take the cube root of each side, so that 3 here cancels the 3, and y equals 2 raised to the power 1 over 3 will be left by this side. Similarly here, I would take the cube root of each side so that the 3 cancels is 3 and y equals 6 raised to the power 1 over 3. So I've just gotten a solution for y. But then I am asked to solve for x. We are asked to solve for x. Can you remember from here where we said 2 raised to the power 1 over x is equal to y? So bringing that down, 2 raised to the power x is equal to y. So 2 raised to the power 1 over x is equal to y from here. And y is 2 raised to the power 1 over 3. Cancelling the 2 on both sides. 1 over x is equal to 1 over 3. When you cross multiply, the value for x from here will be equal to 3. By this other side, 2 raised to the power 1 over x is also equal to y, and y is 6 raised to the power 1 over 3. How do we solve for x? From this side, I'm going to take log of both sides. So this side I will take the log, and this side I will also take the log. From the law of logarithm, can you remember that this power can cross to this other side? And then we're going to have 1 over x log 2 equals log 6 log 6. The 1 over 3 will also cross. The 1 over 3 will also cross the same way this one crossed. So if we have to solve for x, what's the next thing we're going to do? Let me get rid of this 3 by multiplying both sides by 3. So 3 times 1 over x from here, log 2, is equal to, if you multiply this by 3, that cancels this 3, and then only log 6 is going to be left. Now from the law of logarithm 2, this 3 can also shift to this other side. If it shifts to that side, it then becomes a power. So we're going to have 1 over x log 2 raised to the power 3 equals log 6. 2 raised to the power 3 is equal to what? 8. This equals log 6. Dividing both sides by log 8 will give 1 over x equals log 6 over log 8. And when you cross multiply and finish up, the value for x would be equal to log 8 over log 6. So this is the second solution to the question. X can be equal to 3. X can also be equal to log 8 over log 6. But then let me prove if these solutions are correct. For the sake of time, I'm going to plug in just the first one. X equals 3. X equals 3. Let's prove if that is a true solution to the question. If x is equal to 3, by this other side, we're going to have what? 2 raised to the power 3 plus 3 over 3 minus 4 raised to the power 3 over 3. Will this be equal to 12? This 3 over 3 is 1. 1 plus the 3 is 4. And then 2 raised to the power 4 is what? 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So I'm having 16 here. Minus 3 raised to the power 3 over 3 is 1. 4 raised to the power 1 is equal to 4. So when you subtract this, it is equal to the 12. That shows that x equals 3 is a solution to this question. Thanks for watching. For more exciting videos like this, kindly subscribe to my channel.